So today we've got a bit to get through. First, we'll just start with the quotient rule, and once we've done the quotient rule, then we'll have a look at our plan. So I emailed you all the plan. I'll be able to see how many students open the email, see if we had a look at it. Now, the part of the plan today is to also do derivatives and exponentials, and the reason is we'll find the quotient rule quite easy, and I'll also have a chat with you guys about the higher order reasoning problems that we've alluded to, but maybe I'll bring up my email and talk more about that there too. So there's a little bit to get through today. So the quotient rule follows directly from the product rule. In fact, we can use the product rule to prove the quotient rule, and that is one of the questions that does pop up a bit later in the textbook. But here's the rule: if we have two functions, u divided by v, then the derivative is u dash v take away uv dash divided by v squared. Now, it must be in that order, okay? You can't mix up that order. Make sure you write it out like that. So we're going to encounter this first problem here, and we could actually differentiate this using strategies we already know, right? We could split the denominator and simplify, and then differentiate. You could do that process, all right? But seeing as we're learning about the quotient rule, we're going to apply it here. So u is always the top function, so that's going to be, hey Darcy, x to the half take 5x, and v is always the denominator. Okay, we're going to differentiate both of those, so we'll go for u dash and v dash, and then we just smash it together in that order. U dash times v, so u dash times v. So here's f of x, we're moving to f dash of x. F dash of x equals u dash times v. That's in brackets, u dash, and then v. I'm putting it in brackets because it's all of u dash that multiplies all of v. The safe thing to do is just put everything in brackets. U dash times v, take away, and then we have u times v dash. Okay, u dash v, take uv dash, all on top of v squared. All right, that's it. Okay, so full marks there. Okay, we could expand and simplify and maybe collect a few of those like terms, but we'll get full marks right there. Remember, the only time we're required to simplify is if it says show that the answer is this. Okay, over to here, u is going to be the top function, 3x take away 2. V is the bottom function. Now I might, I'll write v here. It's x to the 5, take 3x plus 2 to the power of a half. Now, u dash will be 3, and v dash, I'm writing all the way over here because it's going to be very long because we have to use the chain rule to differentiate it. We have a function to the power of n. Function to the power of n. So we're using the chain rule. We differentiate it first. All right, so the derivative of that part is there, f dash of x. We multiply it by n. We multiply it by the function, and then the function has the power of n take 1 on it. Okay, so we've got the quotient rule, but compounding that now with the chain rule as well. So we've moved from v to v dash. Okay, there's the function, there's n, f dash of x, n, f of x, n take 1. Okay, now we're just going to smash all that together according to the quotient rule here. Now I might write this one out underneath because this one is very long. All right, we have f of x again, so we're going to f dash of x, and it's going to be u dash v take away u and then v dash. Okay, so u dash v, take away, u, and that whole thing is our v dash. All on top of v squared. Now when we square this denominator, it's going to get rid of the square root, so we can just write that denominator without the square root. Full marks there. Alright, so I'll stop there. We'll get straight into the quotient rule, and I'll bring up the plan.